vision and machine learning, deep learning. Also, he's a MVP for AI. And Haritha is joining us from Australia, Melbourne. Am I right, Haritha?
Yes, yes.
Oh, that's nice. And thank you so much, for making time on Saturday and taking time out for this wonderful session. So, guys, Haritha will be talking about Azure Machine Learning Studio, which is, a one-stop shop for lot of things, right from developing models, deploying them, and managing them. So, over to you, Haritha. We are eager to learn ML insights from you, and all the best.
Thank you. Thank you, Priyanka. And I wish you all a good day and welcome for the Global AI Meetup, the Singapore version. So it's really nice to have you here with today talking about some interesting stuff about machine learning, AI, and all those stuff. Cool. We'll start. So my session is going to be about Azure ML Studio. One is like the one-stop shop for all the ML needs that we have right now with Microsoft and with on the cloud of Azure. So this is not going to be about the legacy things that we had before, and this is going to be about all the new things coming in and what sort of things that we can do here. All right. As Priyanka introduced me previously, I'm working as a researcher for La Trobe University, attached for the AIS, Australian Sports. Kind of like a weird combination where sports and AI is working. Weird and interesting combination. Also, I'm an MVP in AI with Microsoft. So that's about me. So we'll move forward and we'll see what sort of things that we can do with ML Studio and what sort of things that ML Studio is there that we can use. Right. Yeah. My basic research is about computer vision, deep learning, and sports analytics. So if you have any question on these areas, just ping me. So I'll be more happy to help you out in those areas. Cool. Uh, in the today's sessions, we had a lot of talks going on and a lot of sessions going on about how the machine learning models built and how sort of like how the management of those machine learning models should goes on and all those things. One of the major things that we need to address is ML ops. I guess there have been many sessions down there about ML ops and how the model management and those things goes on with that. So in a data science perspective, or in a perspective of a machine learning engineer, we have to look on each step that we going through in the machine learning building life cycle. you know uh, as a machine learning engineer or a data scientist, we have to go through from preparing our data till the deployment of the web service through using many tools and technologies. So previously we were used to use many open source technologies onto that. We were used to use Python, and we were used to use Jupyter notebooks, and you name it, PyCharm as IDs, and many things were used there. Everyone, and some even use the things like CUDA frameworks and everything to do their deep learning calculations. So the best thing that we have in Microsoft Azure Machine Learning now is we have the ability to concat all these things together and go forward with a single life cycle and single stop where we can use our own tools in their cloud environment. So I would say this machine learning, this new Azure machine learning thing is kind of a connection that we can make with the cloud, where we can leverage the power of cloud without going out from our comfort zone of using our own tools. So in my case, in my personal opinion or the personal experience, I'm more like an open source guy. So I use Linux for my as my personal use machine. Plus, I'm more of a Python guy. So in my case, I had my own tools, my libraries that I use every day. Some of the libraries like OpenCV, which I use for video and image analytics, which were a bit hard to manage in normal like drag and drop ML Studio things because they had many platform dependencies, such things. So machine learning, that Azure Machine Learning Studio, that new one, has resolved all the questions and pretty easy to use. So we'll go through the things that we have in there and what we can do there. So I'm pretty sure you are familiar with this interface, the machine learning studio, the new one, ml.azure.com. So in here, we have a set of tools that we can use based on our need. So what I'm going to do is I'm going to walk through in which level you guys are in and what are the things that you can use based on the level that you are in. Right. The first thing, notebooks. So, when it comes to configuring a machine that can do machine learning experiments or the deep learning experiments is pretty tedious. That is going to get a lot of time of yours to configure the machine and use that thing for your experiments, because you have to install Anaconda and you have to install all the packages. You might have to configure your GPU on that. So it's not that easy task. That's, trust me, that is sometimes going to get you like a full work day to configure your machine. So in this case, if you don't need to go for that kind of environment, because the notebooks are there. You can just spin up a notebook VM or like a compute Azure compute environment, which is having a notebook, a pretty managed Jupyter notebook instance where you can do all your notebook like machine learning or the data science tasks. When it comes to automated ML, I'm going to talk on that later. It's more like, I would say it is better to build prototypes with automated ML, and it is better to have an idea what kind of algorithms going to work better with our data kind of thing. All right. The designer thing, yeah, I'm going to talk on that later with my demo that I have. So it is more like a managed environment where we had this thing before uh, with the normal drag and drop interface that we had as ML Studio before, and it is a evolution of that. And the main difference between the previous one and this one is we have the chance to configure the compute resource that we're going to use. In the previous one, we didn't had that option to select which compute that we're going to use. Right. This is a simple screenshot. I'm going to talk on all those things because I have less slides, more like a demo kind of thing. So yeah, this is a basic screenshot of the notebook environment that we have. Yeah, and the studio that we're going to use on the demo. Right. But this is and this part. This is one of the most interesting parts I see on ML Studio, the new thing. The data sets and the data stores and all those things in one place. When it comes to the data sets of Azure Machine Learning, there are main two types now, the file data sets and the tabular data sets. Tabular data sets, we all know, which comes with CSV files or might be TXT files, you name it, or the TSVs. Everything which comes in tabular format goes in tabular data sets. So in most of the times, the data that we have in the corporate environment is tabular. The data might be sitting on Azure SQL, or might be in a blob storage, which is in a single file. So you can encapsulate as a data set, like Azure Machine Learning data set here. When it comes to file data sets, images, videos, or the audio files mostly comes under file datasets. So we'll say you have set of images that need to be classified in a computer vision application. So you can put all the images in a blob storage and then make it a dataset registered in your Azure machine learning environment. So experiments is the place where you have all the things together. I'm going to show the thing in my demo. Pipelines is a pretty cool thing to manage MLOps models, always, because at the end of the day, every machine learning experiment that we run is going to end up in a ML model in a pickle file or somewhere. So we're going to use that thing to build our web service. So that is going to end up in the models tab. Endpoints, the endpoints is the endpoints that we open up for the application in a microservices architecture where the REST APIs call with each other. This is the thing going to be up there with as a web service, which is pretty cool to manage everything, even the web services inside the same place. Right. When it comes to the the compute resources, we have the training clusters, inference clusters, and attached compute also with here. Attached compute is a resource which we have in our environment. It should be on Ubuntu right now. uh, Else you can't attach a compute resource like that. You might wonder what kind of scenarios we want to attach another computation resource for Azure. So like for an example, in a real world example, in our case, with our labs, we have a pretty big uh, setup of deep learning rig, which is having the new NVIDIA 2080 Ti's and everything on a single machine, which is running Ubuntu. So what we can do is we can just attach that machine as a compute resource, and the model management and those things are going on Azure. So that is an environment that where we have to use this kind of scenario. uh, and when it comes to these data stores, so you have to know the main difference between the data stores and the data sets, because you might get confused behind these two places. When it comes to data stores, it is more like a storage abstraction over the Azure storages that you have. We'll say your data is in a blob. We'll say your data is in a Azure SQL. You can't just directly connect that thing into your Azure Machine Learning workspace. So what you have to do is you have to just connect that thing, use an abstraction called data stores, and say your Azure Machine Learning environment. Okay, we have data in this particular location on Azure. So I'm going to leverage those data in my machine learning experience, or like machine learning experiments. Then you can make it a data set or use in your experiment as you want. The last one, data labeling. This is a pretty cool tool when it comes to computer vision applications, because we face the difficulty of having labeled data a lot. Labeling data is a pretty tedious task. Sometimes we might have to build our own tools to just label the data. In this case, Azure is providing the facility just to label the data as we want and just export the files as we want. Right. As I said previously, my rest of the things is going to be more in a demo way. Before jumping into the demo, what I'm going to do is I'm going to show you what kind of demos I'm going to show, and what sort of things I'm going to do. So in my case, I'm going to like in my demo, I'm going to talk about data labeling first, where that is the main point where the data is coming in. And then I'm going to talk about AutoML, where we don't have to do any code and just go forward with building an application. And for that, I'm using this particular data set, which is one of the most popular data sets out there, iris classification. So this is classifying three flowers based on their petal length, petal width, sepal length, and the sepal width. This is an open source data that you can download from the internet, from the UCI repositories. So one of the major multi-class classification examples used in any place like Kaggle and even in the university syllabuses. The next thing I'm going to use is pretty different. In this case, I'm going to use a coding environment, or like a coding thing to do, like to show you how we can use our own tools and techniques to do a machine learning experiment. In this case, what I'm using is the PIMA Indians diabetes classification. This is a binary classification dataset, which is pretty popular down there, and everyone is using this thing. So in this case, I'll come up with the architecture after explaining the things later, and I'll show you what sort of approach that I took to build this particular classification. Right. So yeah, before jumping into the QAs, we'll go forward with the demo. So any questions so far? So uh, I'm looking for the questions that coming in. If you have any questions, you can just type it up, and I'll answer the questions there. Okay, I'm going to pop up my screen here with the demos. Right. Share the screen. Right. Okay. I'm pretty sure. Pretty sure you can the screen, right? Cool. Yeah. As we all know, now the machine learning studio that we have is this, the new one, ml.azure.com. So everything I talked previously is here in the left hand side. Previously, this machine learning studio used to have two different versions, the basic and the enterprise. But from this Jan, there's no two different versions. Everything is under enterprise. That means everything is under one shelf, and the machine learning, the thing is not coming with a price tag now. Previously, the enterprise version was with a price tag. Right. As I told previously, one of the main things I'm going to talk about first is the data labeling. In my session, the session is about the journey of a data point through ML Studio. When we have the real world data, we don't have the leverage of having labeled or managed data always. So in this case, we have to like take a look on how to train the data and how to label the data and those things. Yeah, if you go for the data labeling thing, so in this case what I'm having is I have set of images of cats, dogs, and fruits and flowers that has been stored in a Azure blob storage. What I need to do is I need to label this data based on the labels that we have. So the data labeling experiment, if I go there, I can see I have nearly 3000 images that hasn't been labeled with these four classes: fruits, flowers, cats, and dogs. I have only labeled few of them. So the pretty cool environment here is if I go for the label data, yeah, it shows all the images that I have in that particular blob storage. I'll show you how to create that thing. And it comes to a simple interface like this where I can use the keyboard shortcuts. Like this is a cat, so I can just tell, yep, that's a cat. And if I press alt enter, that goes for the next one. Yep, this is also a cat. So this is a fruit, this seems a fruit, so the fruit is going to be 3. So then this is a flower. Pretty easy like that. You can go forward and you can just stop as when you want. And with managing your ads and the accesses, you can share this thing with your peers. The one of the major advantage of this is, we'll say you have a set of interns, might be, or set of peers that will help you out of labeling this kind of data. So you can go forward and ask them to do that thing with your data labeling thing. So after like labeling the data, it will come here saying, all right, you have completed 18 images and like that. So as I said previously, you can go for image classification labeling with multi-class, or maybe image classification with multi-labels. That means one image is having multi-labels. Or else you can go for object identification with the bounding boxes. Uh, that bounding boxes are coming in the COCO format, or instance segmentation, which is under preview right now. So, and the next thing is, we'll say, yeah, I'm going to just say test. Uh, what you have to do is you have to create a data set from here. For creating a data set, the best option that you can do is first store your data in a data store. That means first encrypt your data in a data store and get it as a data set for here. So that is all about data labeling. You can just wrangle around this data labeling thing, and I'm pretty sure you can have an idea of what sort of things that you can do there, right? And I guess you get an idea here. And since there's no questions coming in, sorry, I'm moving for the automated ML part. In the automated ML, the best thing is No need to do any coding. No single coding line is going to be there. What you have to do is you have to just select the data set that you're going to build. As I said previously, I'm going to use this iris data set. uh, then what I'm going to do is I'm going to select, yeah, iris training experiment, which or I'll say iris or automated ml, which I had previously. The target column is going to be the species, and I have a compute resource, I guess. I have to create one here. So in this case, you have to have a dedicated compute resource, which is going to cost a little, but in an automated ML environment, that is not going to be that high. And I would say, will say, you don't have any deep learning things to be done, deep learning kind of things to be done, some computer vision kind of things done. So don't go for the GPU based computations. Always go for the CPU, because that's the easiest one, or the cheapest one that you can go forward with. We'll say compute auto ML. Yeah, it says it can't have this one. Yep. Maximum number of nodes. We'll say one. Right. Yep. I'm gonna create the thing. It'll get some time, I would say. After that, what you can do is you have to select which kind of machine learning problem that you're going to solve. Right now, this is only supporting the classification, regression, plus time series forecasting. You can see here it says enable deep learning. When it goes there, it says for featurizing text data. You can do a computer vision classification right now here. You can do that thing right now here. So what you can do is, we'll say you have a tabular set of data which is having set of textual data. Then you can enable deep learning there, and it can be used for featurizing those textual data. Else that is going to use something like bag of words to do this kind of tasks. So this is going to be a classification. So it'll validate the data, and it'll create the machine learning experiment down there. After creating the machine learning automated ML machine learning experiment, it is going to go for these experiments. You can see this automated ML thing is running there, and yeah, it's starting yet. But if I go for the thing I ran previously, this one, if I go for my child runs, you can see the runs that I have completed previously, and what sort of models that has been built there. Everything can be looked on here as you move forward, and you can just select which machine learning algorithm suits better for your data from this particular one. You can see this has been tried many classification algorithms, and it has been sorted out with the accuracy. You can see the algorithm voting in Assemble is working well with the particular iris dataset. Even you can see the model explanation out there, but still it's in the preview version. So that's about all the automated ML and how that works. The best thing with automated ML, as I said previously, is about no code environment, but you can say, okay, I have built this machine learning model, and you can even make that thing into the production. That is pretty easy. Yep. Not going to talk lot about this design environment, which is very similar for the thing that we had before, where we can add like drag and drop and interfaces like this, and then just try out the data transformations and everything just by connecting the dots like this. It is a pretty cool environment, and I would like to show something for you here. In here you can have like what kind of compute environment that you're going to use. And the next thing is one of the major thing is you have to select the compute target. We'll say you are building some kind of a application which need deep learning or some kind of complex computation power. then you can leverage the power of the GPUs here. So that's all about the design environment. Not going to talk a lot on that because this is pretty easy and everyone used to be more familiar with this environment. All right. The next thing I'm going to talk about is about data stores, because I see in most of the cases, our engineers get bit confused about data stores and data sets. So data stores, as I said previously, is just an encryption for the data that we have in our Azure environments. These data not need to have in a particular, like the similar resource group or something that might be in a different resource group on Azure. So in my case, what I'm going to talk on the next is I'm having the data sitting on a Azure SQL database, which is which is in Azure SQL database, and I'm going to get that thing as a Azure machine learning data set as an abstraction. So that's in that case, I have to use this data stores to make that thing an abstraction to here. So you can just uh, data store, you have to give a name here, and then from all these places, starting from Azure Blob Storage, it goes through Azure MySQL databases even. You can use any of these Azure places to get the data to inside for your Azure machine learning experiments. In most of the enterprise environments, I know your data is sitting on SQL databases, which was mostly on Azure. So what you had to do is you had to just get that thing into this data store and register that thing as a data store. You can see most of my data that is sitting here are sitting on Azure Blob Storages or in Azure SQL databases, and some in the file shares. So this one, as I said previously, the one that we use for data labeling is a file dataset because it is having files that is on a blob storage. But this one, which is the Azure SQL data store, is on a SQL data store. So what I'm going to show is this one. Uh, if I run this thing, this is on my Azure portal. I guess the dbo.iris is there. Yeah, the tables are here. You can see my dbo diabetes is also here. Right. Cool. Right. Now what I'm going to do is I'm going to show you the experiment setup, which I said I'm going to use the tools in open source mostly, and show you how we can integrate those things with Azure. So yeah, this is the one I'm going to do. So I'm going to show up that thing on how this is going to work. Right. Give me a second to go back for my space where I have this one. Uh, I'm going to share the screen. Okay. Right. All right. It's coming in. Why it went for that one? Yeah, we talked about all these things, and next experiment I'll explain what I'm going to do and what sort of tools I'm going to use there. All right. So in this case, this in PIMA Indians diabetes classification, the data is sitting in a CSV file. The data is going to be in a binary classification task. So the data is sitting here as a simple CSV file. What I did was I put this SQL file, CSV files into a Azure SQL database. So you might wonder why you put a CSV file into a SQL database, but in a demo purpose, I wanted to do that thing because I wanted to explain, like, because most of the cases you have the data sitting on your SQL databases, so you can start from here. So this Azure SQL database is outside from my workspace. This is my workspace, Azure ML Studio workspace. This is outside from my workspace. So This connection down here, this connection down here is the connection I'm going to use. Uh, like I have to use this connection down here to tell, okay, this workspace is going to use this particular Azure SQL data, the data in this particular Azure SQL database. So this one is the abstraction, the data store. First, I have to create a data store. So the data store is going to see this Azure SQL database. After seeing the data store, this data store should be registered as an Azure Machine Learning data set. So that is the main difference. This data set can be in two types, whether a file data set or might be in a tabular format. Since this is in a CSV format, so that is going to be obviously a tabular format data set. Then after that, we'll say I don't have enough computation on my machine. That's the place where I can use the power of Azure Cloud to do my computations. I'm not going to use any computation on my machine to do the tasks. So the data is on Azure. So I'm going to do the computation also, sorry, on Azure. So the model, for the model development part, that is the most interesting part. For the model development part, like you might wonder, okay, Azure is about Microsoft, so we had to use something like .NET. Nah, it's not the case. We can go forward with your pretty familiar interfaces. So VS Code is my favorite IDE. So I'm going to use VS Code with Azure. So all right. So I'm getting a thing saying people can't see my screen. Can you see the screen now? Yeah. Okay. So right. Okay. So yeah, cool. Now you can see the screen. I'm going from the I'm not going to go from the beginning. So as I said previously, this is the Azure SQL database, which is not inside my Azure ML workspace. So what I did was I did an abstraction from the Azure Machine Learning data stores. So the data store then registered into a Azure Machine Learning data set. There are two types, as I said previously, the tabular and the data file data format. So since this is going to be a tabular data that is sitting on a diabetes data set in a CSV format, that is going to be a tabular data set. Right. I don't have enough computing resources and I don't want to use those things. Since my data is sitting on the Azure cloud, so I'm going to use the Azure cloud for the computing too. That's there. Then I'm using the VS Code to do my computation. Look, all my experiments, because that is my favorite IDE. So Python is my language. So I use Python there with Azure Machine Learning Python SDK. So Azure Machine Learning is having two SDKs at the moment, the Python SDK and the R SDK. I haven't used R SDK now. So not that familiar with RSDK. So I have used the Python SDK, which is pretty cool, and having a lot of resources that you can manage your Azure Machine Learning workspace through your Python interfaces and the codes. Right. Uh, Other libraries, scikit-learn, one of the most famous machine learning libraries out there. So I'm going to use that thing. After that, I need to push this thing into my production environment, which can be done in two different ways. One as an AKS cluster, Azure Kubernetes Service, or else I can go with the ACI, Azure Container Instance. Many people ask when to use AKS and when to use ACI. I would say if it is a test and dev environment and you don't have a lot of traffic coming in, go for the ACI, because ACI is the best option for that. If it is going to be a global deployment, which many people going to use that thing, and there might be a lot of traffic coming into your web service, then go for an AKS, because you can scale up, scale down, and do everything on your AKS. So that's a decision that you need to take, whether to go for the ACI and the AKS. In a production environment, I would definitely say going for the AKS would be the best option that you can move forward with. So that is then going out as a REST API. So that's going to be uh, the the architecture or the tools I'm going to use in my experiment where I'm going to show you the thing. Sorry. So yeah. So then I'm going to share the code base down here. Uh, yeah. Can I have the screen, share the screen on air, please? I guess that need to be operated from the admin side. Yep. Cool. Right. This is my VS Code environment. So I have my VS Code environment, and as I said previously, everything is pretty easy on VS Code. What I'm going to show you is the normal environment setup where you have everything can be connected through to your local machine. This thing is running in my local machine. So uh, in after installing your Azure Machine Learning Python SDK, it will show you what sort of ML version that you are using and how it is loaded and all. So what you have to have is your config.json file, which can be downloaded from your Azure portal or from your ML Studio, and then you have to just put your config file in this particular folder and refer for that. So it will get your workspaces down there. You can see I'm using my OSAML workspace loaded here. So if you just list down what are the compute targets I have on my workspace, yeah, I have two compute tasks, CPU compute and compute AutoML, which is an AML compute down there running here there. And if I just see what are the data sets I have like four data sets down there uh, on my machine learning workspace, which data stores on my machine learning workspace. So the data sets that I have, three data set, one of that CDFF data set, which is having cat, dogs, flowers, and fruits images. And I have the diabetes data set, which is having this PIMA diabetes thing, which I'm going to use for this one. And so, yeah, that's all about the environment setup. You can see all these lines has been using simple Python plus the AML syntax, that Azure Machine Learning SDK syntaxes. So it is open source, available on GitHub. So you can just go through that, and a pretty cool documentation is out there on the Microsoft Docs to read on these. Yeah. After doing this thing, what I have done here is I'm going to use a pipeline, as I said previously, for building my thing, because I found pipelines is a pretty cool tool for ML ops. So I'm not going to walk through each and every code step that I have done here. What I have done here is I have my training scripts in this particular file. The training scripts are running in this particular file. So this is a normal Python code where you are loading a set of data into a data frame, and then you separate those things into features and labels, and then you train a model using logistic regression. A simple training code like that, right? After doing this training code, what you have to do is you have to just submit this thing as a web service. So in the experiment pipeline, what I'm doing is chunking up these parts and then giving those parts these particular tasks one by one. And most fascinating thing with these pipelines, and why we should use pipelines more in our ML experiments, is we'll say you have an experiment where you have to use a lot of computation for data pre-processing, but there are something like GPU based computing in data, like training tasks. No need to have that GPU based computer for data pre-processing and like spend your dollars on that. What you can do is you can do your pre-processing on a CPU based compute, and then transfer those data into a GPU based compute when it comes to the training stuff. So that will reduce your cost a lot. We can do that kind of things in an experiment pipeline, which is pretty easy, and I find that thing is pretty useful in most of the environments. So I'm going to just run this code and show you guys like the steps. Like the first steps are pretty straightforward. What they have done is just getting renaming the experiments, and then getting the CPU cluster as my computer, because I'm using the CPU cluster. And then what I'm going to do is I'm going to get the packages and everything configured, so you can say what sort of packages that you need to use. Even because in some cases you have to use some specific conda packages, so you can just say, okay, just use OpenCV or just use sci-fi and those things here. So my run configuration has created. Then I'm going to get my data set down here. My data set is there on the data sets. After that, we all know the estimator is the phase where we use for training some scripts. So this particular pipeline is going to have two steps: the estimator step and the Python's like registering model step. Because after training the model, I'm going to register that model where I can use that thing for making a web service. So the training step is there, and I'm going to put this one. The pipeline registration is up there. Then after that, I just construct my pipeline. Pipeline is only having two steps. After constructing the pipeline is built now. Then I just submit my pipeline for execution. So you can see the pipeline is submitted for execution. So if I go for my screen where I have the Azure thing running on. Uh, uh, so what I can see is my uh, pipeline would come there, and I'll show you how the pipeline is executing there. So I'm going to switch for the screens. Yep. Right. Can I have this screen on the share right now, please? Cool. So in my pipelines, if I go for the pipelines, you can see the thing that I submitted few seconds ago, 46 seconds ago, is down here. You can see my pipeline is having three steps. The dataset is coming here, and model training is right now running. It's finalizing, and register model has not started yet. So it's pretty easy. The pipelines might be bit confusing might be in bit complex ways, but everything can be managed here, and you can see what sort of logs has been done in these particular steps and all. So I would say when you building the machine learning experiments, always go for these kind of pipelines, because that is going to be a pretty easy and a pretty good way to manage your things. So that's about pipelines. Like I'm going to talk about the next thing, which is going to be endpoints, and then go forward with the final conclusions about a machine learning studio and those things. When it comes to the endpoints, till my pipeline is running, so my pipeline is running, so yeah, still running. When it comes to the endpoints, you can see everything I just published is in an ACI, not on an AKS, because this is more like for my development purposes. So in this is a simple REST API which any developer can read out, and this is just going a JSON in and getting a JSON out. So building this simple API also can be done towards your Python environment where you coded on the VS Code. So we'll say whether our pipeline has been completed. Yes, it has been completed. Now, what I'm going to do is I'm going to switch back to my VS Code environment. I'm going to make a trouble for my admin out there again for sharing my screen with the VS Code. Uh, Yep. So right now on my VS Code, can I have the screen on here on live? Cool. So in my VS Code environment, I have set up the web service. So now the pipeline has been submitted, and we saw the pipeline has been completed too. So web service creation can be done easily, and you can say this is going to be a ACI web service. Whether you're going to use AKS, you have to say what kind of AKS configuration, what kind of AKS cluster that you're going to use here. And then for testing web services, we'll see whether the web service is running down there. Mm, so um, I'm just getting whether the web service is running. I guess the web service is there, and I'm just putting a simple patient, like which I created a dummy patient, and then make it a JSON. So my JSON is something like this. Yeah, a JSON like this. And I'm just pushing that JSON for my web service. Yep, it shows it is an undiabetic class by just getting the data from the web service. So if I see my web service URI, so I can get the endpoint like this. So that's simple as that. You can manage all your ML things. The only thing I have done on Azure is just computation, managing the models, plus uh, managing the runs. Rest, the development and the code bases and everything is here in my local environment. This can be just put on the GitHub like that. Even everything can be done. So if you need, like, I have this thing on my GitHub, so you can find it out on my GitHub, and yeah, use for your research purposes. So that's about how you can build that kind of a pretty complex, not that complex, but the setup is having bit of more components in building a machine learning classification through using the new Azure Machine Learning Studio. I'm going to share my screen again. Yes, and I have this thing on the live, please. Right. So we go through all of these steps, which we have used most of the things on Azure Machine Learning Studio. So my final conclusion or takeaway that you to give for you is, don't hesitate to use ML Studio with your own tools and services. So you can get all the things into cloud, and you can do more with that. Open for any questions. So I'll be happy to answer the questions down here. If you have any question like that need to be gone come for me, you can just use this URL, or else you can use my own social media to just ping me out to get any questions to be answered. So that's about it. That's about Azure Machine Learning Studio and how a data point is traveling from a single data point to a web service through to the Machine Learning Studio. So would be here for like 2-3 minutes to answer the questions, or else you can ping me out in any social media channel where I can help you out with your questions. Priyanka, that's over to you. So waiting till the questions are coming. Since I'm not getting any questions down here so far, thank you very much for attending for the session, and hope you guys got an idea about Azure Machine Learning Studio and how that works, and what sort of things that you can do with Azure Machine Learning Studio and all. Yep. Hope you guys do your experiments and do some cool things with the new ML Studio. Thank you. Cheers.